Good morning to all. In this video, we are going to discuss about natural drought, how to analyze the natural drought system. So the natural drought system, okay. So the natural drought system is obtained by means of chimney. So now we have to calculate, first estimate the height and diameter of the chimney. Okay. So this is the natural drought system. So here capital H dash represents height of the chimney column of hot gases. So from this base, the total height is the height occupied by the hot flue gases. Okay. So next, H is the column of cold atmospheric air, and capital H minus small h is the equivalent column of hot gases for the column of cold air. Let us assume that the atmospheric air is PA and P naught is the pressure of the flue gases is Pg, and P naught is the ambient gas. Okay, so we are assuming that P1 is the pressure at grate level, that is the chimney side. P2 is the pressure acting on the grate at open side, and P is the atmospheric pressure acting at the top of the chimney. Rho G and rho A are density of hot gases and cold air. So now the total pressure P1 can be calculated as atmospheric pressure PA plus rho G GH, and P2 can be taken as PA plus rho A GH. Okay, so we stated that the drought is nothing but the pressure difference causing the flow of hot gases. So here the pressure difference delta P is equal to P1 minus P2 or P2 minus P3, P1 minus P2. So here if we take the difference between the pressures, we can get the whole pressure gas as density of air minus density of hot gases into G into H. So this drought is also known as static drought. Okay. So now we are going to determine the height of the chimney. Okay. So let us assume that the volume of product of combustion is equal to the volume of air supplied, both reduced to the same temperature and pressurized conditions. Okay. So now let MA is the mass of air supplied per kg of fuel. MA plus 1 is mass of the chimney gases produced. TA is absolute temperature of the atmosphere. Tg is average absolute temperature of hot gases of chimney gases. Okay. So we know that now we are considering the ratio of mass of hot gases to the mass of air, that is MA plus 1 by MA. For calculating the height of the chimney, we are utilizing the two equations. One is ideal gas equation, PV is equal to MRT, and another one is density equation, P is equal to rho GH. Okay. So here we are considering density of air at 0 degree centigrade or 273 Kelvin, and say temperature is T0. Temperature is T0. So from that we can write rho naught is equal to P by R naught, and rho A is equal to P by RTA, and rho G is equal to P by RTG. Okay. So from this we can take P naught T0 is equal to PA TA is equal to rho G TG. Rho G TG. Okay. So now comparing these equations, we can determine density of air. If we taken the first two equations, in the last equation number 5, if you taken first two equations, that is rho naught T0 is equal to rho A TA. So we can write rho A is equal to rho naught by TA into T0. TA into T0. Okay. So here rho naught is the atmospheric pressure, that is 1.0135 into 10 power 5 bars divided by 287 into TA. So if you calculate that, we used to get 353 by TA, that is the density of air. Similarly, if we calculate the density of gas, we used to get it as MA plus 1 by MA into rho naught T0 by TG. If we further calculate this, we used to get density of gas as 353 by TG into MA plus 1 by MA. So if you apply the density of gas and density of air in the static drought, then we used to get the static drought system as delta P is equal to T53 GH 1 by TA minus 1 by TG into MA plus 1 by MA. So now H1 is the column of hot flow gases. Okay, if you take the difference delta P is equal to rho GH and substituting in the equation, so we know the value of rho G and we know the value of delta P. So if you substitute both, we used to get the height of the hot flue gases called height of the chimney. H1 is equal to H into Ma by Ma plus 1 into Tg by Ta minus 1. Okay. So now this is the height of the chimney. Okay. So if various losses are available along the path of the flue gases, the actual draught available is always less than the theoretical draught. So whatever the value we have calculated is always less than the theoretically obtained value. Okay. So if you are calculating the height of the chimney in water column level, then HW can be taken as 353H into 1 by Ta minus Ma plus 1 by Tg into Ma. Okay. So now we are going to determine the diameter of the chimney. Okay. Before going to determine the diameter of chimney, first we have to calculate velocity of the chimney. So the velocity of the chimney can be taken as C is equal to square root of 2G into H1. Okay. So now that we can calculate it as, if you calculate this, 2G is can be taken as 4.43 into square root of H1. The value of K is equal to 0.825 for brick chimneys. The value of K is equal to 1.1 for steel chimneys. And the mass of gases flowing through the cross section of the chimney is given by mg is equal to rho g into A into C. That is area is pi by 4 d square. And if we calculate the d from d, we can d value is obtained as 1.128 into square root of mg by rho g into C. That is the formula to determine the diameter of the chimney. Okay. So what is the condition for maximum discharge? Okay. So here we know the velocity is equal to square root of 2g into h1. In the place of h1, if you substitute that, h into ma by ma plus 1 into tg by ta minus 1 into 353. So now the density rho g can be taken as p by rho a into tg, and mga can be taken as a into c into rho g. So mass of gas, if you substitute all these values in the above equation, we can determine the mass of gas as K by Tg into square root of Ma by Ma plus 1 and Tg by Ta minus 1. Okay. So now to determine the maximizer condition, the refraction of dm0 by dTg is equal to 0. Okay. So and Tg and Mg are fixed quantities. If you want to solve the above equation, we can get the maximum condition Tg by Ta is equal to 2 into Ma plus 1 by Ma. Okay, that is the condition for maximum